Hey everyone, in this video we're going to be covering calculus, and we'll even get into a little bit of multivariable calculus. So what is calculus? Calculus is a branch of mathematics that studies continuous change. It's divided into two main branches, differential and integral calculus. It was developed independently by Isaac Newton and Gottfried Wilhelm Leibniz in the 17th century. It's essential for advancements in physics, engineering, economics, and others. So let's talk about differential calculus. So briefly, differential calculus focuses on the concept of a derivative, which represents the rate of change of a quantity. Some of the key questions in differential calculus are: how does a function change? And what is the slope of a curve at a given point? So what's integral calculus? It's concerned with the concept of an integral, which represents the accumulation of quantities. Some of the key questions in integral calculus are: how do we calculate the area under a curve? And how do we sum up an infinite number of small quantities? The next thing you need to know for this introduction to calculus is the fundamental theorem of calculus. We'll get into it more later, but briefly, it links differential and integral calculus. It states that differentiation and integration are inverse processes. Briefly. Now let's talk about limits. To understand what limits are, let's look at an example. We start with f of x equals x plus 2. The limit of f at x equals 3 is the value f, or y, approaches as we get closer and closer to x equals 3. If we start at the point 1, 3 and move on the graph until we get really close to x equals 3, then our y value gets really close to 5. Similarly, if we start at 5, 7 and move to the left until we get really close to x equals 3, the y value again will be really close to 5. So we say the limit of f of x at x equals 3 is 5. So the limit of f of x equals x plus 2 at x equals 3 is f of 3. But this isn't always the case. Let's look at the piecewise function g. G isn't the same as f, since it's undefined at x equals 3, but the limit of g at x equals 3 is 5, even though the value at x equals 3 is undefined. So limits don't depend on the actual value of the function at the limit. They just describe how the function behaves when it gets close to the limit. We have a special notation to talk about limits. For example, the limit of f of x as x approaches 3 would be written as this. The limit of f of x as x approaches 3. Here's an example problem. This is the graph of f. What is a reasonable estimate for f of x at the limit as of x approaches 6? The solution here is -3. In limits, we want to get infinitely close. For f of x equals x plus 2, f of 2.999 equals 4.999. Since we want to get infinitely close to 3, but not exactly 3. In case there isn't a value at 3 or the value of 3 is somewhere else. The f of x when x is 3.001 is 5.001, while f of 3.00001 is equal to 5.00001. A limit must be the same from both sides. If it isn't, we say that the limit doesn't exist. Here's an example of the limit not being the same from both sides. Here the limit doesn't exist. Now let's talk about continuity. A function is said to be continuous at x equals a if the limit as x approaches a of f of x is equal to f a. We can also say that a function is continuous on the interval ab if it's continuous on each point in the interval. We can also say that a function is continuous if it can be drawn without picking up your pencil. But more formally, if f of x is continuous at x equals a, then the limit of the limit as x approaches a of f of x equals f of a. The limit as it approaches a from the negative direction of f of x is equal to f of a. And the limit as x approaches a from the positive direction of f of x is f of a. It's also continuous if the graph has no holes or breaks. Here's the graph of f of x. Determine if f of x is continuous at x equals -2, x equals 0, and x equals 3. Take some time to think about it. The limit of f of x at -2 doesn't exist. It's called a jump discontinuity. The limit of f of x as x approaches 0 is 1. And the limit of f of x as x approaches 3 is 0. But it's not continuous at this point. It's actually a removable discontinuity. Now let's talk about differentiation. The process of finding the derivative of a function with respect to an independent variable is what we call differentiation. It's the instantaneous rate of change in the function based on one of its variables. That's the definition of the derivative. For example, given position over time, the rate of change of displacement, or its derivative, with respect to time is called velocity. The derivative of velocity with respect to time is acceleration. If x is a variable and y is another variable, the rate of change of x with respect to y is given by dy over dx. This is the general expression of derivative of a function and is represented as f prime of x equals dy over dx, where y equals f of x is any function. The derivative of a function measures how the function's output value changes. As the input value changes. Thus, it provides the rate of change or the slope of the function at any given point. The mathematical definition of a derivative is f prime of x, we say this little apostrophe is f prime, equals the limit as h approaches 0 of f x plus h, x increased by a small amount of h because as h approaches 0, minus f of x over h. How do we understand this? The average rate of change between 2 points the points being x equals a and x equals a plus h is given by f a plus h minus f of a over h. We also know that the instantaneous rate of change is when h is infinitesimally small. For example, let's find the derivative of f of x equals 2x at x equals 3 using the limit definition. So f prime at 3 equal to the limit as h approaches 0 for f3 plus h minus f of 3 over h, which is equal to 2 because f of x is equal to 2x, 3 plus h minus 2 times 3 over h. And simplifying this down, we get 6 plus 2h minus 6 over h. We get 2h over h. And the limit of 2 at h as h approaches 0, since there's no h in this expression, we just say that the limit is 2. Thus, the derivative of f of x equals 2x at x equals 3 is 2. Now, there are a few different types of notations that you need to know. d of y, or d of f of x, is called Euler's notation. 2, dy over dx, is called as Leibniz notation. And 3, f prime of x, is Lagrange's notation. Now let's talk about linear and nonlinear functions. A linear function varies at a constant rate through its domain. So the overall rate of change is the same as it is at any point. So the derivative would be the same at any point. The rate of change of a nonlinear function varies from point to point. Here are some differentiation formulas that you need to know as a calculus student. You'll need to remember these, though it's okay if it takes you some time. Here are some differentiation rules: the sum or difference rule, the product rule, the quotient rule, and the chain rule. Here are some example differentiation problems. Go ahead and solve them, pause the video, and I'll show you the solutions in a few seconds. Here are the solutions to the differentiation problems. Now, let's talk about integration. Integration deals with finding the antiderivatives of functions, also known as integrals. While differentiation concerns finding the rate of change, integration focuses on the accumulation of quantities. Given the derivative f of x, f prime x of a function f of x, integration allows us to describe the original function f of x, since we can invert the differentiation. For example, if you had f of x equals x squared, then f prime of x would be 2x This is the power rule of differentiation, if you remember from earlier. And the integral of f of x, written with a squiggly line and dx here, is equal to x squared, which was the original function. Integration involves summing small quantities to describe displacement, area, volume, etc. An integral represents the area under a curve over an interval. The interval could be negative infinity to infinity, or it could be two constants. So let's talk about the types of integrals. The first type is indefinite. This is defined without upper and lower limits. So we can say that f of x dx, the integral, equals capital F of x plus c, where c is any constant that would have disappeared by differentiation, and f of x is called the integrand. The definite integral is the other type of integral, and it has upper and lower limits. And finding the definite integral gives you a definite value. Now let's talk about the fundamental theorems of calculus. The first fundamental theorem of calculus is if a of x equals the integral from a to x of f of t, and f is continuous on ab, then a prime of x, or the derivative of x, equals f of x, for x being an element in between the interval a and b. For example, if a of x was equal to the integral from a to x of 2x dt, this would equal x squared. This is the integral. 2x becomes x squared from a to x, which equals x squared minus a squared, since we're taking the values from a to x. And a prime of x is equal to the derivative of x squared minus a squared, which is just 2x. The second fundamental theorem is if f is continuous on the interval from a to b, and f is any derivative of f on the interval a to b, then the integral from a to b of f of x dx is equal to f of b minus f of a. For example, if you have the integral from 1 to 4 of 3x squared dx, then f of x being 3x squared, we find the integral, which is x cubed, and I'll show you some rules to find how to actually find the integrals. But for now, just know that the integral of 3x squared is x cubed. And from 1 to 4, 3x squared dx is equal to f of 4 minus f of 1, which is equal to 63. Because 4 cubed is 64 and 1 cubed is 1, so 64 minus 1 is just 63. Now let's talk about a few properties of integrals. The derivative of an integral is called the integrand. Or the derivative d over dx of the integral f of x dx is just equal to f of x. And this is the fundamental theorem of calculus, the theorem 1 that we covered before. The next property is that an integral of f of x plus another function, let's say g of x, is just the integral of f of x plus the integral of g of x. You can separate them out that way. Another property that you need to know is that constants can be factored out of integrals. So if we had a constant times f of x, we can factor out the constant, making it c times the integral of f of x dx. Now here are some important formulas you need to know to solve for integrals. A few common ones and some key rules here. Now let's cover a few methods of finding integrals. The first method is the substitution method. If we had an integral of this form, and I'll show you an example later, but this is what it would look like formulaically, then f of g of x times g prime of x dx equals the integral of f of u du, where u is equal to g of x, since du over dx equals g prime x. So du is just g prime x dx. And this is where we get it from. So this becomes du, and g of x becomes u, so f of g of x becomes f of u. For example, if you had the integral 2 of x times cosine x squared dx, then we set u to be x squared, du to be 2x dx, since du dx is just 2x, and we carry over the dx, we multiply it on both sides. Then we get cosine of x squared 2x dx, just moving around the terms so it's a bit more understandable. This becomes cosine of u du, and we know from the previous rules that the integral of cosine is just sine. And don't forget to add the constant at the end. And then we have to get the final answer, we have to substitute u. So we have to substitute x squared back in for u. So that was the substitution method. The next method is called integration by parts. And here's the formula for it. If we had the integral of u dv, it's equal to u times v minus the integral of v du. Here's an example. If we had x times e of x, e to the power of x, times dx, then we get u is equal to x, du is equal to 1. We are basically selecting u's, du's, as well as dv's and v's. And we select u, du, dv, and v strategically. Specifically, we pick a u that gets simpler when finding the derivative of u du. So, if back to the problem, if we get the integral of x times e to the power of x, that just equals u times v minus the integral of v times du. And what is du? It's just 1 dx. Just cleaning up a bit here. And this is equal to x times e to the power of x minus e of x plus c. Since the integral of e of x is just e of x, e to the power x. The next method of finding an integral is called partial fraction decomposition. Now all these methods are used in specific situations. And I'll explain this through example. So here's the example. The integral of 2x plus 3 divided by x squared minus x minus 6 dx becomes x squared minus x minus 6. What we're going to do is we're going to factor out the denominator. So this is just x minus 3 times x plus 2. So 2x plus 3 over x squared minus x minus 6 is equal to, this is how we decompose it, a over x minus 3, the first factor, and b over x plus 2. Then we multiply the denominator out to both sides. So a becomes a times x plus 2, and then we get b times x minus 3. Now we can say that a plus b it's a plus b times x plus 2a minus 3b. How did we get this? It's a times x plus b times x, so it's a plus b times x, and then it's 2a plus minus 3b. So we just distributed it out. So we know that a plus b has to equal 2, since we get 2x plus 3. So 2a minus 3b has to equal 3, since it's plus 3. Now we have to solve for a plus b equals 2 and 2a minus 3b equals 3. This is our system of equations. And if we solve it out, we get a equals 9 over 5 and b is equal to 1 over 5. So if we go back to the integral 2x plus 3 over x minus 3 x plus 2, the denominator factored out, then we get a over x minus 3, our previous form that we had here, plus 1 over 5 over x plus 2. And now we can factor out the constants. And we can separate out each function. This becomes 9 over 5 ln x minus 3, this is another integration rule that I showed earlier, plus 1 over 5 times ln x plus 2, and don't forget the constant c. So what are the applications of integral calculus? Finding area under curves is one of them. calculating volumes of solids of revolution is one of them, and another is determining the displacement from velocity, among many other applications of integral calculus. Now let's talk about partial derivatives. Which is actually technically multivariable calculus. So partial derivatives are the derivative of a function of several variables. It measures how a function changes as just one of its input variable changes. While keeping the other variables constant. We keep all the other variables constant. So here's a quick example. The partial derivative of x squared plus 2y squared. We're finding the derivative with respect to x. So we treat y as a constant, and therefore the derivative is just 2x. And if we were to find the derivative with respect to y of the same equation, x squared 2y squared, the same expression, it would be 4y because we're treating x squared as a constant. And that's all for calculus. Thanks for watching. If you have any questions, leave a comment below. If you liked the video, leave a like. And subscribe to stay tuned for any future videos on machine learning and deep learning. And stay tuned for future videos in the machine learning mastery playlist. Cheers.